Welcome to the Power of ERDC. My name is Tim Reeves, and I'll be your host today. On the modern battlefield, two things are essential: power and water. All people, especially soldiers in combat operations, require adequate water supply. Energy demands are at an all-time high, and energy requirements on the battlefield continue to increase. But these operations often take place in austere environments where success of an operation depends on having critical, dependable, and resilient logistics available when needed and where needed. ERDC is helping advance research in this area, leveraging the unique capabilities and facilities and world-class research team at ERDC's Construction Engineering Research Laboratory, or CERL, in Champaign, Illinois. By collaborating with industry and academia, ERDC acts as the crucial facilitator, taking innovative blue sky ideas and developing, testing, and transitioning these technologies for the soldiers who rely on them. Joining us for this discussion is Dr. Andy Nelson, Director of CERL. Sir, welcome.
Thank you. Good to be here.
Glad you can make it. Glad to have you in person and not, virtual, the big blue wall here.
It's nice to be. This is the first time I've been in Vicksburg in over a year, so it's good to be here.
Glad you hit. So let's start off and kind of simply explain what we're talking about today: operational energy and operational water. Kind of define what those are.
Sure. So, so first of all, thanks. Appreciate the opportunity to be here. This is an important topic. As you said, the availability of energy, the availability of water are critical to maintain operations, both for a deployed force in a conflict, but also in contingency operations for the missions that the Corps of Engineers has in emergency response and disaster operations. So, generally speaking, when we talk about operational energy and operational water, we're talking about the provision of energy and water on the battlefield. And so that can be in a rear area where you have a larger group in a rear area, higher density of power usage, greater availability of water, greater resources available to soldiers that might be deployed there. So things like showers and laundry and latrines, all the way up to the very forward edge, where we work in close collaboration with partners who work at soldier scale systems, sort of small scale systems. But the ability to get energy there to charge systems, charge batteries, to remotely operate systems in austere environments and remote environments, and then to provide water just for drinking, drinking water, and the ability to make and prepare food and MREs for soldiers as well. So it spans the gamut, and there's a continuum there, from the very, very tactical edge down to that rear support area. But across all of that, these things are really interconnected with each other, water and energy. And that's why we tend to talk about them together. And a lot of the work that we do that supports both of those two areas tends to be intrinsically linked, both in terms of the customers, the people that we support, the operators that use it, and then the technical experts within ERDC who are working on that kind of work.
You mentioned we and your team at CERL. How did CERL become, and like I said, I mentioned this later, how having visited there, how did CERL become kind of this epicenter for this kind of research, in both areas?
Yeah, so it really started probably about 15 years ago. CERL started in a program, developing a program that was really focused on contingency-based planning. So the virtual forward operating base program, thinking about how do we not only provide energy and water, but actually how do we identify a site for building a forward operating base? How do we more efficiently plan the design of that site and plan something that's scalable? Because generally speaking, we go into a place, a location, and we have one set of solutions. But if we stay somewhere for a period of time, those solutions change and they adapt. Mm-hmm. And so that planning process isn't static. It's a continuous process that's really interlinked with kind of the operations of a base. So around 15 years ago, made these investments to start looking at forward operating base planning. And then that really kind of brought in the close nexus with energy. And it was really some of the subject matter experts that we brought in, who came in and started working on those programs that identified this opportunity and need to focus on operational energy in particular, recognizing that significant amounts of fuel that is burnt on the battlefield is wasted. It is not used. It goes out the stack of the generator as waste. And a lot of that was just around good planning and being able to use good planning to match your loads and your requirements to the generating capacity that you have on a forward operating base. So that kind of started the early work. And then over time, with that work, we've invested to establish a couple of very unique facilities. And so one of those is at CERL. It's called the ERDC Forward Operating Base Laboratory. And we have a facility in Champaign where we have a lot of the typical generation assets, energy generation assets that you would have, surface laid distribution, all of the systems that are used for that, as well as the types of structures that are used or were used at the time in contingency construction. So stick-built wooden barracks huts, some tented structures. And it gave us the ability to kind of start developing and testing at a pilot scale different types of equipment. That naturally sort of lent itself to developing the water mission as well. And that's in part because, again, those things are intrinsically linked. Generally speaking, the provision of water in any location, but in a deployed location, is very intrinsically linked to the energy required for filtration, whether that's reverse osmosis filtration from found water, or if it's the generation of water or reusing water. So we kind of tend to think of those things together. And so over time, I've built out that capability as well at our forward operating base laboratory at the EFOBL in Champaign. And then also through partnership with Fort Leonard Wood and the Maneuver Support Center there, we cooperate a training facility and a testing facility down there called CBTEC, the Contingency Basing Integrated Training and Evaluation Center.
You got it. Nailed it.
I got it, I think. Yep.
I saw you working the figures.
I got to get them all down there. So, but that site, more than 20,000 soldiers a year come through and train there. It's co-located with the Army Prime Power School, with the Army Engineer School. And down there, we can go from what we test at CERL in a pilot scale, make sure that these things are going to operate, and then go down and actually get soldier hands-on and soldier feedback in using these things in an actual operational environment. So it's kind of been an organic process over the last 15, 16 years, really, to go from kind of original concepts around contingency-based planning that then kind of neck down into the areas where we really had expertise, and then where we also saw a need that needed to be filled, which really ended up being that energy and water space.
Let me get off script just for a second. You mentioned CEDATEC and kind of also the facility you have at CERL. How important to advancing these types of technologies, whether they're energy or water technologies, is that soldier touch point that you're able to get at CEDATEC and with the other organizations down at Fort Leonard Wood? How does that help accelerate and get that technology faster?
Yeah, so there's a couple of things. So soldier engagement is critical to all any of our technology development, to make sure that what we're building is something that is solving a real problem and is also usable in the way that soldiers operate in the field. The benefits that we get from the EFOBL and from CEBATEC is the very fast feedback loop on these things. So we do a lot of work in integrating into large exercises, planning events, things like this. And actually, just today, I was at the airport this morning and bumped into one of our lead researchers in the operational energy program, John Goebel. And John was headed up to Joint Base Lewis McChord to go work with the Triple Nickel, talking about operational energy technology and hybrid systems, giving some hands-on training to people who are going to go use this in the field. But EFOBL, it's literally out our back door, right? So people can walk out there and go be able to look at, experiment with, develop a technology and make sure it's ruggedized to the point where we can get it deployed. At CEBATEC, one of the biggest benefits that we have is the regular rotation of soldiers through, which gives us loads. It gives us sort of the characteristics of how these things are operated and used in the field. But then we also have permanent staff who sit there. So we got a couple of folks who permanently sit there at Cibatech and are able to monitor equipment, are able to run particular experiments, duty cycles, things like that, which is really an important step so that when we do go out in the field, when we do put something into the hands of a soldier, whether that's in an operational environment or in a large exercise, we have a high level of confidence that it's gonna operate the way that we expect it to. And so those things all can kind of collapse the timeline that it takes to do that, because we kind of have direct ability to inject in, which is really important.
Yeah. Previous conversation you and I had about energy and operation water was calling it liquid logistics, which I think I'm going to trademark at some point. Hopefully somebody hasn't yet. But just the amount of fuel that it takes to do so, and water, that all works together.
Mm-hmm.
So that liquid logistics, I kind of guess, is a perfect way to say all of this inclusive.
Yeah. Yeah, absolutely. And again, it comes back to, so I'm an environmental engineering by training. And environmental engineering, we talk a lot about the energy water nexus. And so in civilian infrastructure in the continent of the United States or anywhere around the world, the provision of clean water is intrinsically linked to the availability of energy to treat that water, move that water. And so when we talk about that in an operational environment, an deployed environment, that energy also generally comes from a liquid source of energy in JP8 or diesel.
Mhm.
And so there are significant logistical challenges with moving those volumes of liquid around, whether it's fuel or water. But then they all kind of get coupled together when you start thinking about that. And they're large. You're moving things with trucks and large vehicles. You have a constant need for resupply, because this isn't, it's something that comes in, it gets used, and that's it. And so we really do think of them together that way. And I think no matter where you are on that spectrum, if you're talking about water treatment in, Chicago, Illinois, or you're talking about water treatment on a remote island or in a remote location to provide drinking water, at some point that is generally has to be connected back to energy in some form or fashion.
You mentioned that, for CERL, this is sort of a 15-year growing mission space, but why does it seem that the call for these technologies has been at such a high demand now? I'm curious as to, aside from news cycles or whatever, but there seems to be an increasing call for these kind of solutions more so than I remember.
Yeah. So I think part of it is understanding the problem. And it's difficult to understand the problem if you can't measure the problem. And so there's been a lot of work, and the ERDC team has been very involved in this over the past 10 years in metering and monitoring. So being able to measure the amount of fuel used, measure the amount of energy used, what it's used for, and how that's utilized. And it really highlights some of these issues around inefficient use of our fuel. And so that really drove, I think, an awareness to the problem. The kind of changing mission set and focus more on dispersed operations and quick maneuver rather than long-term settled into large bases in kind of that traditional form has really amplified the challenge, because if a dispersed force is going to have it, they're going to be carrying it with them, or they will have to have a regular resupply. And so things that limit their ability to move and move quickly become very critical to enabling them to do what they need to do for the operations that they have. So I think that's really brought into focus, and in particular when we talk about it in the Indo-PACOM AOR, in the that's a place of a very harsh environment, very dispersed operations on islands, in remote areas, places that it's difficult to get things in and out, places where getting things in and out is very obvious, and that kind of movement can be things that puts people in harm's way, and can also indicate what we're doing, and what's going on in an area. So I think that has all increased a lot of the focus on it, but it's also, there is this connection to what's available, right? So a lot of the solutions in operational energy and things we've worked on for the over the past 10 years have been on hybridized systems and hybrid power systems. So these are just like your hybrid vehicle systems that essentially operate a generator at 100% to charge a load of batteries, and then use those batteries to discharge. That allows you to either surge your load if you need more capacity than your generator can generate, or it allows you to operate your generator at nearly 100% capacity all the time, which is far more efficient for the generator, not wasting energy out the stack. So there's been a lot of work in energy storage and the control systems and in all the space to sort of bring this to fruition that has coalesced in the past 5 years or so, that I think is really accelerating the art of what's possible in this space. And that gets people excited. And the more that people become aware of those kinds of operational freedoms that it brings when you're not worried about the logistics tail as much, it starts to become something that we focus on a lot. And so that's really what's driven the growth of the work to not only be research inside the laboratory, but pretty much all of this we are doing in close collaboration with industrial partners through cooperative research and development agreements, through other transactions, through contracts with companies that are developing this technology.
You mentioned understanding the problem and appreciating the problem. I guess, how do you measure success in this area? So you understand the problem, you're confronting the problem. How do you know if you've measured success or met the problem?
Yeah, so the number one and easiest is, are you reducing the amount of fuel that you're using, right? And so we have time and time again been able to demonstrate that with hybrid systems by working with partners in AFRICOM, in EUCOM, falling in on units who are already operating in a particular location, bringing in a new piece of equipment to replace generators that they may be using, and seeing massive drops in the amount of energy, the amount of fuel that is required, because we're operating a hybrid system rather than just a standalone generator. 50% reduction in fuel usage, 60% reduction in fuel usage. So I think that's the number one thing that it's the quickest, it's the easiest, it's the thing that people see, because that changes the way that force on the ground has to operate, because they have to spend less time refueling generators. They have to spend less time coordinating logistics to get the fuel in, to procure fuel. They have to spend less time with security associated with all those activities. So that's really on the ground is where the savings becomes the most quickly realized. But also in costs, right? So reduction in the cost of operations, that is a very real factor. And then, one of the main driving factors for this was in Iraq and Afghanistan, the number of casualties that were incurred due to the logistics supply lines to be able to bring fuel and water into operating areas. And so that is soldier safety. It's life saved. And so those are harder to quantify in this environment right now, but are very real and are an important driver for all of it.
And I'll let the audience know that over the next couple of months, we're going to have a chance to meet and interview some folks in the operational energy and operational water teams at CERL to talk about some of the technologies and work that's being done. But let me ask you, what are some current or some advancements or technologies or equipment that are good examples of this work that you'd like to highlight?
Yeah, so there's a couple of, for us, especially on the energy side. So we have metering and monitoring, trying to understand what we use so that we can better inform decisions. Get demand reduction. So I think we're gonna, I know you're gonna have on the podcasts some folks that are going to talk about things that we do to improve the energy efficiency of structures and systems in a deployed environment. So you can gain energy efficiency and reduction of fuel usage by operating more efficiently. So we have looked over the years of different ways to construct buildings and structures, or to provide, in the case of recent work with the 11th Arctic Airborne, how can we add insulation to existing structures, existing facilities that is easily deployable, can be easily put in place to reduce the amount of energy that's required to operate a particular facility. And then we have the demand reduction. And so I talked about, hybrid power being a major one of these, but really, a focus here is, any source. So it doesn't matter what the source of energy is, that we can use any source and we can power any load. And being able to do that gives operational flexibility to the people in the field who are using these systems. And so whether you have a system that's a diesel generator, or solar panels, a small deployable solar system, or a hydrokinetic generator, or as is going on right now, a lot of focus in the Army on developing microreactors, so modular nuclear energy, regardless of the source and how you're getting your energy to be able to use it efficiently, apply it efficiently. Those are things that we focus on a lot. So we got some really interesting work right now on the north end of CERL. There's a whole bunch of small scale systems that are combined energy storage with solar, and so it is really focused on how do we operate small sensors, equipment in very austere environments for long periods of time without having to go in and refuel a generator. So that work is directly impacting operations right now, drug interdiction operations, and things along the southern border as well, where we are able to in place things that you couldn't have put in place previously, or in order to do so would have exceeded the capacity of the force to be able to deal with the logistics associated with it. So those kinds of things are having direct impact now. And then as I said, hybrid power in all of its capacities at different scales is something we're really focused on, and have some significant efforts underway right now to try to scale this up to large scale systems as well, large scale deployable systems.
And I know some of those technologies you mentioned have been the subject of recent articles, the nanogrid and such, that we will make sure we include on the podcast website, the powerverdictpodcast.org. We're going to include some links to those articles that will highlight some of that work you've been talking about. You mentioned industry, working with industry earlier in academia. What are some industry partners, or let me ask you this question: how important is it for ERDC, CERL in this case, to have partners in industry to help come alongside to advance these solutions?
Yeah, so I think in pretty much all of these cases, there are components of things that we have developed in a laboratory. In some cases, it probably applies more on the water space. But then, the integration of existing technology that's either commercial off the shelf or near commercial off the shelf is a key part of all of this work. So yeah, industry partnerships through many different, in many different forms are kind of drive a lot of what we do here. I think a recent example, a very good example right now where we're focused is working on transitioning some technology that's been developed through DARPA, focused on how do we generate water from air, right? So this technology is, concepts have been around about how to be able to harvest water from the air. It's an energy intensive process. It's an inherently very energy intensive process. But there are, when we think about energy and water together, there are mechanical processes that happen in the energy generation process, where we can utilize some of the waste products from that to improve the efficiency of the water from air process. Right now, from the concepts that the Army has and the ability to provide water in an employed environment, these systems that exist that are kind of commercial off the shelf solutions for water from air, they don't meet the efficiency marks that we need. It's too much fuel in for the amount of water
Right.
that you get out. You're not getting a good benefit there. But when we couple that with thinking about how do we harvest some of the waste heat and waste energy from the energy generation process, suddenly we can start to get numbers that start to look like they're making more sense, and they are getting us closer to where we need to be. And so we're working through a couple of cooperative research and development agreements, CRADAs, with companies in developing and advancing things that have been developed on the industry side, and trying to integrate that as well then with the energy generation technologies that we already have that are program of record systems, so we can see, are we able to get these to a point where they're meeting the mark that can operate at the efficiency that we need to make them viable for the Army. The work that we do in operational energy, again, this is almost all done in hand in glove with industry, companies that have developed ruggedized inverters, ruggedized battery systems, the ability to design these systems in a way that they can be used and operated in an operational environment, moved on aircraft, deployed rapidly, redeployed, etc. That's all work that we do in close partnership with industry.
For time's sake, I'm going to kind of blend two questions here for a second. We mentioned the unique facilities and capabilities CERL has. How is it let me ask you this: how is CERL built fundamentally that makes it adapt so quickly to this mission space? And the other part of that question is what are some of the future problems you see the Army having or the Department of War overall having in adopting some of these solutions? So I guess it's more of an adaptation and an adoption question.
Mm-hmm. Yeah. So I think the first half of the question, how is CERL built in a way that is able to respond, and ERDC writ large? There's, I think, a key thing to that is this program, as we kind of built into this program area, it was largely driven by individuals who came out of operational experiences and understood the problems on the ground, right? So these were people who were in uniform, who were working in the field and understood the challenges that were there. And so very quickly able to understand and communicate those, working closely with technical subject matter experts that could develop solutions and develop the technical solutions. The closeness with which we partner with the Prime Power School and 249th Prime Power Battalion, as well as the Engineer Schoolhouse, is also key to this, and the PME2S2, who's ultimately the product manager for a lot of these operational energy systems. That helps us be tied to the requirement, to the user community, and understand what they need. I think the challenge in adaptation versus adoption, et cetera, right? This is the case across the board. Is that, a lot of these are systems where there are thousands and thousands of them in deployed environment, right? So that are already in the inventory. So it isn't just an overnight solution to go, purchase something like that. That's just not feasible, right? The budget's not there for that. So thinking about things again that kind of gets at that any source, any load. How can we improve the ability to utilize the equipment that we have more efficiently, rather than thinking about how do we need to replace every piece of equipment, but rather how can we use an existing program of record generator and couple that with a new battery energy storage system, and then the controller that is able to operate between those two pieces of equipment is really the important piece that enables a legacy piece of equipment to operate with a new technology, but operate more efficiently.
And that buys you more time for that new stuff, new equipment to come on board.
It buys you more time, but it also gives you more operational flexibility, because rather than thinking about everything as being a bespoke system for this particular need right here, it's, hey, we have this part and this piece, and we can put these pieces together. And so that might be a combination of solar, diesel generation, battery energy storage, and coupling all of those three things together in one location. And then perhaps in another location, you don't have solar, maybe you have hydrokinetic. You have a small hydrokinetic turbine that could operate, silently. And you're using that in conjunction with a generator that maybe you use on and off only when you have the ability to, or don't have concerns about needing to operate silently or quietly.
So one of the threads that we commonly pull on the podcast here is ERDC's ability to take research from one side of the house and apply it to the other side of the house, whether it's from military engineering to civil works, vice versa. How is this work? How can it be applied, or is there a chance for it to be applied on the civil works side of the house?
Yeah, so I think as we think about kind of advancing the any source, any load concepts, right? The same people that provide that power in a deployed environment may be called upon to do that in emergency response, as well as the industry partners who might be doing that. So I think this can help advance things that then impact our mission for the emergency support functions and for the public engineering support functions that allow us to operate more efficiently when operating in a disaster response environment. At this point, we're pretty much exclusively focused on the military mission, and that's really where kind of the customers are. It's where there's it's where the need is the greatest, because of the very sort of the tyranny of distance, right? The challenges of getting fuel and water where you need it. That does exist for sure in the contingency or in a disaster response environment. But if we're doing that here in the continental United States, we also have a lot of partners in industry and commercial partners who are kind of coming in and doing that work as well.
So when you look on a daily basis and you hear updates from your op energy teams and operational one, are you ever surprised about where they're operating next or where they're testing next? Because I mean, in some conversations I've had with them, it's like, this part of the United States, this part of, the Pacific Ocean, this, is pretty extreme. It's pretty impressive.
They certainly get a lot of frequent flyer miles. And yeah, so I think, one key that we've had is a relationship with operational commands that has enabled a lot of that kind of direct integration to some very far-flung locations that really have demonstrated how valuable this can be to the units in the field. So we've had a relationship with AFRICOM over the last probably 6 to 7 years that has seen a number of different systems on the continent of Africa, as well as training events, working with partners, African nation partners, in training on how to use these systems, training on operational energy planning, and so seeing some of the places that folks are doing work in Africa. But then as far up as just a couple of weeks ago, I was up in Fairbanks at Fort Wainwright for the JPMRC, Joint Pacific Multinational Readiness Center 26-2 exercise that was going on up there, and we had both demand reduction systems up there, insulation systems for an Arctic shelter, as well as a hybrid power system up there. And operating those pieces of equipment, those guys, our operational energy team was out all over the course of 3 days. They got 30 inches of snow, and it's negative 15 degrees, and they're trying to work out the kinks on a system and learning from that experience. And it's a very different experience than what you're dealing with if you're going to the Horn of Africa, for instance.
Right.
Very, very different environment. But yeah.
Well, sir, listen, I appreciate your time. I appreciate now. For the people listening and watching, you didn't travel to Vicksburg, Mississippi just for
No, I did not.
I would like to tell people that you did, but that's not the case. But we're glad to have you in person. And thankful for the conversation.
Yeah, absolutely. I'm glad to be here and enjoy the conversation and appreciate being able to talk about the great work that folks are doing at CERL and across all ERDC.
Absolutely. So with that, I'll thank our audience for joining us as well. If you'd like some more information, you can email erdcinfo@usace.army.mil, and you can also visit our website, poweroferdcpodcast.org. And with that, I'll say thank you again and see you next week.